Here we go. Okay, so let's talk about what we already know. This is a unit circle, so the radius is 1, and the center is at the origin. Okay, so thinking about that, all right, we want to look at, for each point on the circle, we have a degree, we have a radian blank, and we have an x and a y blank. All right, so for every angle coming from the center, so look, see this angle right here? That angle happens to be 30 degrees. All right, it has a degree measure, a radian measure, and then there's a point that goes with it. So we're talking about the point in the coordinate plane that it corresponds to, and those are significant. But before we start with our 30s, let's start with the easy ones, what we call the quadrant angles. All right, so this one's 0 degrees. What do we have up here at the top? 90. What do we have over here? 180. Down at the bottom? 270. And you add 90 to that, and we get how many? 360. Now this one over here on the right-hand side, it's the only one that has two different sets of angle measures. All right, we start at 0, we end at 360. All right, so now let's try this in radians. Ready? Yeah. Yeah, you can start with a pencil or you can start with a color. It doesn't matter. All right. Okay, so 0 degrees is also 0 radians, yes? Okay, notice. All right, that's the only place they're going to match. All right. What other one do we know? 360 is what? 2 pi. Well, if 360 is 2 pi, then over here on the other side, 180 is pi. Well, if that's pi, what do we have up here on top? Pi over 2. Guys, I use that blank as the fraction bar. It just fits better that way. You see what I mean? Okay? So if this is pi over 2 up here, then what do we have down here? Pi and a half, right? Which is 3 pi over 2. That is pi and a half. All right? Okay, now let me just show you something real quick as we count those around. They're 90 degrees apart, right? They're called our quadrant angles because they split the coordinate plane into the 4 quadrants. Hold on, orange, good. So these are my quadrant angles. Putting in orange. Okay, but let's talk about counting around in radians. They're 90 degrees apart, which means they're pi over 2 apart. So look, I have 0, I have 1 pi over 2, I have 2 pi over 2, I have 3 pi over 2, and I have 4 pi over 2. Do you see it? Okay, so we're going to do that a lot. All right, so now, if this radius is 1, what is this point right here at 0 degrees? 1, 0. Okay, what's the point up here at the top at 90 degrees?
0, 1.
0, 1. Over here at pi and 180 degrees? Negative 1, 0. And then the last one down at the bottom? 0, negative 1. So that first family, the quadrant angle family, not too bad, right? We're going to switch colors now. Y'all ready?
Wait, were you supposed to do that in the color?
Well, you didn't have to. You can do that in regular pencil.
But
Okay. Now you need to use a different color for the next one. Okay. Our next family we're going to do is the pi over 4, the 45 degree family. All right. Now remember what yesterday we talked about reference angles, and the reference angle is how far you are from the x-axis. All the angles that are 45 degrees from the x-axis are in the 45 family. So these two, I'm doing mine in pink, and these two. Yeah. Highlight those crisscrosses. All of those are 45 degrees. All right, now don't draw this in, but do you see that? That's 45 degrees. That's 45 degrees. This is 45 degrees, and this is 45 degrees. That family is all 45 degrees away from the x-axis. All right? So we'll plot that in. All right?
Would you put 45 degrees on the bottom?
Nope. Okay, now let's figure out all of our degrees first. Ready? Everybody here with me? Okay. Ready? I'm at 45. What happens when I add 45 to that? Who do I land on? 90, but that's not in the family. What's the next one? 90 plus 45 is 135. If you add 45 to that, you land on, I just call this a checkpoint, 180. What's 180 plus 45? 225. Plus 45 is 270. Plus 45 is 315. And 315 plus 45 lands me on 360. All right. As you go around, you're always going to land on pi and on 2 pi, and those are your checkpoints. Okay? All right? So it made sense because when we land on pi here, we're like, okay, well, actually, we didn't land on 180. It equaled 180, and then we just keep adding all the way around. All right. Radians. If 90 degrees is pi divided by 2, then 45 degrees is pi over 4. Put that in. So now we're still going around by the same size angle, still that 45 degrees, but we're going to do it in radians. So look, that is 1 pi over 4. This is 2 pi over 4, which simplifies to pi over 2, right? So what's this one? 3 pi over 4. 4 pi over 4 is my checkpoint. Do you see that? Then what's the next one? 5 pi over 4. And then the next one is 6 pi over 4. That simplifies. What's this one? 7 pi over 4. And then 8 pi over 4 is the same thing as 2 pi. And I'm done. Not too bad. All right? So look, I've got all of my angles in. Now I have to figure out that point. So this next part, don't draw this because I'm going to take it off after I put it on, okay? All right, so I have this radius. What I'm going to do is I'm going to draw a vertical down to the x-axis. Do you see that triangle right there, the right triangle? Okay, so what's the hypotenuse of that right triangle? 1. Okay, what's this angle right here? It's 45. So tell me about that triangle. What's special about it? It's a 45, 45, 90, right? It's isosceles right triangle. Okay, so I'm going to take that off. Hold on. Undo, undo, undo. Okay, I'm just going to go to another sheet. You do not have to draw this. And we're going to talk about that 45, 45, 90. Okay, so I have this point up here, xy. Okay, this point down here is at the origin. So do you agree with me that this is x and this is y? Yes? And this is 1, because it's the radius. Okay, what do you know about x and y since this is a 45, 45, 90? They're what? Tell me. They're the same, right? Okay, so we could say y is equal to x, true? All right, so how do we find x? Nope. What? No, we don't use the ratio.
You do the little
That's the whole point. We're finding the ratio.
thing, like you, the proportion thing.
You can use the proportion thing. Oops. Yep. Or you can use that guy. Who is that? Pythagorean theorem, right? Is it a right triangle? Yes. All right. Both sides are x, so it's x squared plus x squared equals 1 squared. Yes. All right, so that's 2x squared equals 1. X squared is 1/2. Come on. So is it plus or minus? Not this time it's not. It will be later though. Okay, square root of 1 is 1. The square root of 2 is the square root. Now listen, will you ever see it like that? What are we not happy about? Square root in my denominator, so I multiply times the square root of 2. Usually we just do the shortcut for this. The 1 over the square root of 2, you copy the radical to the top and take the symbol off the bottom. Remember that? Okay, so that is what x is. So is x the same as y? Yeah. So what we know is this point is the square root of 2 over 2. square root of 2 over 2. All right? The x value is square root of 2 over 2. The y value is square root of 2 over 2. Okay, so Mackenzie said you could use that ratio. Remember the ratio from the other day? That 1, 1, square root of 2. All right, was 1a, square root of 2a. Well, the square root of 2a was equal to the hypotenuse 1. Look, isn't that the same thing? Yeah? Okay, so you would really want to use the ratio, but if you forgot it, Pythagorean theorem works. All right, so going back, we know that this is, again, I'm using these as fraction bars. Square root of 2 over 2, square root of 2 over 2. But the thing is, circles have symmetry. Yes? Mm-hmm. So if it's square root of 2 over 2, square root of 2 over 2 in quadrant 1, what do I have over here? Negative square root of 2 over 2. My y value is what? It's negative, really? Positive square root of 2 over 2. Quadrant 2 is negative positive. What do we have in Q3? Negative, negative. So negative square root of 2 over 2. Negative square root of 2 over 2. And last but not least, in quadrant 4, I'm positive negative. So square root of 2 over 2. Negative square root of 2 over 2. And I'm done with my 45-degree family. Okie doke. Pick a new color. I'm going with blue. All right. The next family we're going to do is the 60-degree family. It's the one right here. Go across. There's 60 degrees. All the angles that are 60 degrees away from the x-axis. Okay, the 60-degree family. Notice, this is not a rotation, all right? This is 60 degrees. We don't rotate over to here. That one's not 60. We reflect. Do you see that they're reflections? You see that? Okay? All right, so let's put in our angles with degrees. Are you ready for that? So I've got 60. What happens when I add 60? What do I get? 120. I add 60 and I land on my checkpoint 180. Add 60 to 180, what do you get? 240. Add 60 to 240 and I get 300. Add 60 degrees to that and I land on my second checkpoint 360 and I'm finished with the degrees. Okie doke. What is 60 degrees in radians? 60 degrees in radians. Well, let's think. 60 degrees times pi over 180. What is it?
1/3 of it.
Yeah, pi over 3, right? So this is pi over 3. And just like the pi over 4s, we're just going to count around. Okay? So we start at 0. We count. This is 1 pi over 3. What's the second one? 2 pi over 3. And this is 3 pi over 3, which is pi. Right? All right, so what's this one? 4 pi over 3. Add it again, we get 5 pi over 3. And last but not least, 6 pi over 3, which is 2 pi. All right? How do you feel about it?
So the 60 degrees doesn't have a checkpoint on the y-axis.
Not on the y. It skips over it. Because you're going in 60-degree angles. So you go from here to here, and then you skip over it. Okay? So your checkpoints are 0, pi, 180, and 360. All right. So now the hard part is the point. Yes? Okay, well, we're going to do the same thing. We're going to think about this triangle right here. I'm going to make another page and we're going to draw it. What was our angle that we were looking at? 60 degrees. Does that make this a special right triangle? It does. This is 1. It's a 30, 60, 90. What was that ratio we did for 30, 60, 90s? 1, 2, square root of 3. But the 2 is the hypotenuse, yes? Well, my hypotenuse is 1. So this is the short leg and the long leg. So what's the short leg? If my hypotenuse is 1, what's my short leg going to be? Half. Remember, because that's half. Remember the equilateral we drew? Okay. All right. And so this is a half. What do we have on this side? Square root of 3 over 2, or half square root of 3, right? So this is my 1a, 2a, square root of 3a. All right, so if this is on my unit circle and this is my origin, here's my point x, y, what's my point? What's my x value? 1/2. What's my y value, my tall value? There it is. Okay, so go back to your circle and put 1/2 here and square root of 3 over 2 here. Okay. All right, now that we have those, how do we get the other family points? Well, this is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. So, negative 1/2 in quadrant 2, positive square root of 3 over 2. Both of them negative here. So, negative 1/2, negative square root of 3 over 2. Oops. Okay. And then positive 1/2 over here, negative square root of 3 over 2. All right, so once you get the point for the first quadrant, the others are easy. We just have to fix the correct signs. Almost done. One more family. Okay. I'm switching to green. You pick a new color. Okay. Our last family is the 30-degree family. These are all about the special right triangles. Guys, how many points are on this circle? Infinitely many. We're only labeling the special ones, the quadrant angles and the ones from our special right triangle. These are the ones we memorize. The rest of them we use our calculator to find. But these are the ones we memorize. So this is the 30-degree family. 30 degrees, oops, gotta change my color. 30 degrees away from the x-axis. Okay, so these are the ones that are close. All right, now, we do 30 degrees last because it lands on a lot of others, okay? We do it last. All right, so we're working around our circle in 30 degrees. So I've got 30. What's the next one I land on? 60. Then I land on 90. Then I land on 120. And then I land on, who's this? Why is 150 the only one that's in the family? Well, it's the only blank we have, right? And it's the only one that's 30 degrees away. Then I add 30 and I land on my checkpoint, 180. Add 30 to that, what do we get? 210. Then we land on 240, then 270, then 300. Who's my other? 330. And then I land on my last checkpoint, 360. You see it? Do you see why we do 60 before we do the 30? All right, because we're going to land on top of them and they're not in the family. Okay, now that we have those, time to do our radians. If 60 degrees is pi over 3, then 30 degrees must be pi over what?
6.
Okay, same exact way, but this time radians. Ready? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, what's this one? And that makes sense because the next one is 6 pi over 6, which is pi, yes? What's this next green one? 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, what's this last one? 11 pi over 6, and that's good because that would make this 12 pi over 6, which is 2 pi. We good? All right, so this point is easy because what? Think about this triangle right here. What kind of triangle is it? It's a 30, 60, 90, right? Except this time, I'm sitting on the long side and the short side is vertical. So what's this point?
3 square root of 3 over 2.
It's the square root of 3 over 2, 1/2.
How come it's not just 1? If the radius is 1.
The radius is 1. So the x value is here and the y value is here. Okay? But if you just take your 60 degree one and you flip it, right? It's the same triangle. So we're done. We just have to fill in our points. So here we go. Negative, positive. So negative square root of 3 over 2, positive 1/2. Negative, negative. Negative square root of 3 over 2, negative 1/2. And positive, negative. Positive square root of 3 over 2, negative 1/2. And I have 50 blanks, and they're all filled in. And it's 50 points. Okay? So, if you miss a sign, you lose the point. Okay, so there's the biggest issue. So what do you think people mess up the most? The points, definitely. Which 2 points do you think they get confused the most? Which families? 30 and 60. So would it be nice to have a little mnemonic to help us to remember that order? Aha, I have one. Okay, so this is all filled in. What quadrant do you need? And then you can get everybody. We need quadrant 1 points, right? So I'm going to take these 5 and I'm going to write them down top to bottom like this. I have 0, 1 at the top. Right? Yeah, you can do it on the back. All right, I have 0, 1, and then moving down that arc, right, I have 1/2 square root of 3 over 2. I have square root of 2 over 2, square root of 2 over 2. I have square root of 3 over 2, 1/2, and last but not least, 1, 0. In order. Now look, if I take these and I can rewrite them, watch this. Starting with the x values. This is the square. Notice that they're all over 2 when they're in fractions. Do you see it? They're all over 2. So the denominator is 2. I've got the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, the square root of 3 over 2, and the square root of 4 over 2. You see that? It just so happens that 3 of those simplify, right? This top one is 0, this one is 1/2, this one doesn't simplify, this one doesn't simplify, but the square root of 4 is 2 divided by 2 is 1. You see it? Now how do I get the other side? Go the other direction. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and the square root of 4. Okay, all you really need are the middle ones though. Those middle 3 are the key. All right? So I'm working down, it's 1, 2, 3, and working up, 1, 2, 3. All right? Will that help you remember their order? Okay. All right. So the ones that I really think about you needing are these 3, because the top one, the 90-degree point and the 0 point are easy. But look, you've got 1, 2, 3, 1, 2, 3. It just so happens that the square root of 1 is 1, so you don't need a square root symbol on it, right? Got me? Okay? So hopefully that will help you put those in. The other way I think about it is when I'm looking at my unit circle, the 1/2 is short and the square root of 3 over 2 is long, right? Okay? So when I'm looking, don't draw this on your thing. When I'm looking at my 60 degrees, this is the short x and the long y. You got me? So that's 1/2 and then square root of 3 over 2. When I'm looking at my 30-degree triangle right here, that's the long x and the short y. Okay, that's how I keep it straight in my head. The 30 degrees is long on the x and short on the y. Okay, and vice versa. Okay, so what we're going to do after I stop, oh shoot. No, it did, it recorded the whole thing. Yay, everybody clap.